This water feature was designed to overlay road noise with serene babbling brook noise. We wanted to provide a clean source of surface water for pollinators and wildlife in general.
The job is starting, and we will utilize most of our excavated soil to create the high ground around the stream above the reservoir. Here on the Front Range of Colorado, we want our reservoirs to be at least 3 feet deep so we don't have to winterize the pump. At 7.4 gallons a cubic foot, our reservoir will store about 400 gallons. This should be enough to run the stream bed that we've designed. You can see the drop rocks that we've selected and roughly placed that we are going to use in the stream bed.
Start at the bottom of the stream bed utilizing underlayment to protect the liner. As we move up the stream bed, we are packing soil around our drop rocks under the liner so that the water flows over them. Pro tip: using pieces of underlayment on top of the liner for extra protection when placing heavy boulders. Now we run water down the stream looking for any leaks out of the sides and adjusting our drop rocks. We now have the drop rocks dialed in and the stream is holding water. Ideally, we like to have the water level at least a couple of inches below the top edge of the liner. This helps to future-proof the stream.
Voila! We've added pea gravel, one of the most important pieces to support the ecology of this water feature, by providing lots of surface area for beneficial bacteria. After this step, we will test the stream again. It should run without losing very much water. If you're losing water, check the edges. It is more likely than a leak in the liner. We select pumps based on how we want the water feature to feel and to keep the water oxygenated and healthy. For every foot of width in the stream, a 1,000 gallon per hour pump would make a mellow trickle. Between 1,000 gallons per hour and 2,000 gallons per hour would be moderate. Over 2,000 gallons per hour would be dramatic whitewater. Smaller pumps need to run more often to oxygenate the water. We always put union fittings on our pump outlet hose to make the maintenance easy.
So this is the pump and it goes in down into the reservoir. And then this is the float that shuts the pump off. If the water level goes down and it goes to a level where the float tips down, then that indicates the whole system to shut down. Something to note is the length of the lead here. You don't want it to be too long or else it will get stuck on the ridges of the tube of the water reservoir. So that needs to be the right length but still long enough so that it can go up and down as needed. And these are the ridges of the water reservoir that the float could possibly get stuck on if the lead was too long. So as we're rebuilding this water feature, there was a hole in the original liner, we just discovered this piece of sharp metal that may have been the culprit. So when you guys are making water features, make sure you check for sharp random pieces of rebar, wire, something. Alright, so after finding a leak, we relined it, partially rebuilt, and now we're running the water. Hey! Woo! It's going down!
I was at the Rock.